So hello everyone. This video talks about the concept of IPC, which stands for Inter-Process Communication. So the word inter-process communication, as this word itself implies, this form of communication is useful to communicate between two processes, again two or more processes, or two or more threads. So as we know, threads are what? Threads are nothing but a lightweight process. So threads are the lightweight process, and we want a mechanism so that which could help in communication between two or more processes or two or more threads in a proper sequential way, so that there is no deadlock, there is proper synchronization. So IPC is one that form which helps in the communication process. When it comes to terms like deadlocks or synchronization, for these things we have a pretty much different concept, but the main objective of IPC is the communication part, and the communication between process A and process B can be done in multiple ways. Like it can be implemented with the help of pipes, it can be implemented with the help of message queues, then it can be implemented with the help of shared memory. Message passing is also one such technique. Then it could be indirect or direct communication. So it could be anything. So that means the communication between two process can be achieved with the help of these techniques. So these are the, you can say, the types of inter-process communication. Okay, so the inter-process communication can be done either with the help of pipes or message queues or shared memory, anything. So what we'll be looking at, we'll be looking at the pipes and the message queues. So this is the objective for us, the pipes and the message queues. So first let's start with the concept of pipes. Let me just add some slides. So if I talk about pipes, so pipes is a mode of communication which is half duplex. So this mode of communication is half duplex, and it is used to again communicate between two or more process. So half duplex means, let's say we have process P1 and we have process P2. What P1 will do? P1 will write. So this is the operation that will be performed by P1. And what P2 will do? P2 will read. So P1 will write its whatever contents it has in a file, let's say, and then those contents will be read by P2. So this is a half duplex method, means P1 will always be writing at a time, at a given point of time. P1 will always be writing something. Let's say it is writing something in a file, and from that file P2 will be reading. So this is the main meaning of half duplex method, because at a time only either a process can read and the second process could write. So this is half duplex. So it is similar, this scenario can be compared to the scenario of filling the water with a tap or a bucket. So let's say if you fill the water with the tap into a bucket, so what will happen? The water will keep on the bucket will keep on filling with the water from the tap, and the filling process is equivalent to the writing into the pipe, and the reading process is retrieved from the pipe. So in the same way, like you fill the bucket with the water, so at a time, let's say the P1 here could be the tap here, that tap is continuously pouring water into the bucket. So at a point of time only this operation is being done, that the tap is continuously pouring water and the bucket is getting filled. So this is the example of half duplex method using pipe. So the file which I talked about here, this file basically is known as the named pipe or FIFO. So this is a very common, you can say, name when we talk about the term pipe, named pipe or FIFO. So that means that whenever a process writes its content to a file, that file is known as FIFO, or the first in first out file, and it is a special kind of file which is on your local storage and which allows two or more processes to communicate with each other by reading or writing from that pipe. So the named pipe is nothing but a form of a file, because where exactly are we writing the contents? We are writing the contents on this file. So this is the file where we are writing the contents, and from this file we are reading the contents also. And the this file is can be created with the help of the function mkfifo. So this is the function which can be used to create the FIFO file. And how, what exactly is the syntax of this function? So let me just write the syntax. Int mkfifo const pointer path name mode t underscore mode. So this is basically the mkfifo file, that the syntax of the mkfifo file that we are creating. So if you look at the arguments here, the first argument is the path name where this file would be created. So automatically you will be giving the specifying the path name where you want the file to be created, and then the second argument specify the modes. Okay, the different modes or the different permissions that are associated with a given file. So what are the permissions that are generally associated with a pipe file? So the permissions which are usually associated with a file are represented in the form of numbers, or you can say integers. Okay, so like we have integers 0, 1, 2, 3, 4, 5, 6, 7. So let me just write 4, 5, 6, 7. So these are the integer values. So if I talk about 0, so 0, what does it specify? So 0 specifies no permission. So if you write here 0, this would specify no permission, means this file has no permission associated with it. Then that means the user cannot perform any operation on that. The 1 number, it signifies the execute permission. Okay, so if you have one, if you have one written so here, then that means the file name which you have given here, you can execute that particular file name. The 2 specifies the write operation. The 3, now what does 3 specifies? 3 is basically a combination of 2 plus 1. So that means the file has 2, means the write permission also, as well as 1, that is the execute permission also. So 3 is 2 plus 1, so 2 stands for write and 1 stands for execute. So instead of writing 2 comma 3 for write execute, we just write the number 3, or instead of writing 2 comma 1, 2 for write, 1 for execute, we just simply write 3. Then that means that the file has write and execute both the permissions. Then 4 specifies the read permissions. uh, fifth specifies, fifth is again equivalent to 4 plus 1. So 4 specifies the read operation, 1 specifies the execute operation. That means the file has read and execute permissions only, not the write permission. Then 6 specifies 4 plus 2, again read and write permission. And finally 7 specifies 4 plus 2 plus 1. That means the file has all the permissions, the read permissions, the write permissions, and the execute permissions also. So this is how the different modes here that is specified, that the argument specifies will have some integers value associated with it. So it could have number like maybe 666. So 3 digits stands for 6, one digit stands for user, this stands for group, and this stands for other. So that means if I have 666, that means all the user, the group, and the other, everyone has the permission to read and write on this file. All the users of the system have the permission to again read and write into this particular file. And these are also specified by certain references, like read, write, execute will be specified as RWE, and read and write would be specified as RW dash. Okay, and like read and execute would be specified as read dash execute, because there is no write permission, so we have dash here. There is no execute permission, we have dash here. And here we have dash wx, because there is no read permission here. This could be specified as r dash dash, because only read permission is here. This could be specified as dash dash w dash, because we have only the write permission here. So this is the different modes, uh, the different integers which specifies that what kind of file is being used. Now let us see one program which implements this concept of writing and reading. So let me open this one file. So yes, I have this program here. So this is one program, okay, which implements the process of inter-process communication with the help of named pipes. Okay, so and obviously named pipe means we will have a FIFO file that we'll be using. So what this program is doing, so initially you can see we have the libraries already imported here. Then start with the main program. Now you see first a file descriptor that is written, and one file path name. So this is the path name that the user has given. So this is the FIFO path name, FIFO file name, where you want your FIFO file to be created and stored. So they specify the path name here. Now what you are doing, you are creating the FIFO file. So this was the function that we saw, that using mk FIFO function you can create the FIFO file, and the first argument is the path name. So this is the path name here, okay, which is specified in this mkfifo function. So I have written this particular variable name here, this pointer name here. So this path name is stored in this pointer, which is again written here, and this specifies the permission as already discussed. So 666 will 666, or let's say 777 will execute the type of permission that it is associated with. Then we have declared two arrays here, and then we start with the while loop. So while one means one stands for true, means this loop will always execute. If we had 0 here, this loop would not have executed. So open the FIFO file for write only. Now this program, so what is the objective of this program? We have two programs here. One, this is the program 1, okay, and we have another program P2. Since we want to achieve named pipes or the interprocess, we have to show how the P1 and P2 will communicate. What we will do, first we'll write the program where P1 will write and P2 will read. Okay, next, and where it is writing, it is obviously writing into the FIFO file. And next what we'll do, next P1 will read, okay, and P2 will write this way. Okay, so and where it will be writing, it will again be writing into the FIFO file. So this is the objective of the two programs. So this is the first program which is writing first. So you can see we have opened the FIFO file, okay, for writing. So this is the my FIFO file, again the same my FIFO file, and it is opened in write only mode. We have used the open system call here. Now as soon as we open it, since we want to write first, so we will use the fgets function. Okay, so fgets function, what this function does, it takes the input from the user. So this is the input array 2. So you can see we have initialized here that this is the character array 2, which has 80 characters in it. So array 2, which will be input from the user, which should have maximum only 80 characters, and this will be taken from the standard input. And as soon as we take the input, take the input from the user, we write it into the file descriptor here. So we write that. So again you can see write the input string on the FIFO file and close this. So this is the file descriptor here. Where we got the file descriptor? We got the file descriptor. Let me just. So we got the file descriptor at let me just start it again. So we got the file descriptor at this particular point here, ft. So this ft here specifies this particular ft file descriptor. So eventually it is doing what? It is writing into this mkfifo file only, right? Because this is the file descriptor here. File descriptor is opening this mkfifo file. This mkfifo file has this particular path name here. So eventually you are writing into this particular file name, and what you are writing? You are writing this string which you got from the user, which should have maximum of 80 characters, not more than that. Okay, and then we are closing that file descriptor. Then okay, so this operation was the write operation. Okay, so next, what this particular, as I just told you that the first program, what it will be doing, it will be writing first and this would be reading first. Okay, and after that this would be reading first and this would be writing first. So the write part is done for P1. Now we'll implement the read part. So this is the read part here. What read part would be doing? Again, now we are assuming that the P2 program has already written in a file and now we are reading from that file. So again a file descriptor is being opened in the read only mode, and I read from that file descriptor. I read the array 1. So you can see the array which I wrote here was array 2. This was something different. So let's suppose I have written here hi. Okay, and the array 1 is different. So maybe the array 1 could have by written here. So these are two different things. So it is writing hi, but it is receiving by from the second program. And then I am printing the message that I have just read, that is by. So this is the read and write aspect of program 1. Now coming to the program 2. Now what program 2 will do? Program 2 will read first. Now so you can see program 2 reads first. Again same sequence of actions would be there. In this particular case, what will happen? You have first the read call, the the code for the read program. It would be reading first and then it would be writing first. So this is the write code. So how again it, since it is reading first, then that means contents have already been written by P1 in the mkfifo file. Okay, it just have to read that file. So again the same path name is given here. It is creating the FIFO file, and now first it is opening in the read only mode. This thing is same for both the programs, because both the program needs the mkfifo file for the read and write operations. Both programs need two different character arrays. So there you can see the array name was array 1, array 2. Okay, but in this particular case the characters name are str1 and str2, because obviously both of them are reading and writing different things, right? So we can't have the same names here. We have different names because they both are reading and writing completely different things. So now I have opened this mkfifo file in the read only mode. So I open it in the read only mode. I read it. I read the string str1, which has maximum 80 characters, and I print it on the console. Now what I will do, I will write it, I will write the content into a file. Now again I will open the mkfifo file. What I have to be, what I should write, I will be getting the contents from the standard input. I am writing it and I am closing the file descriptor. So this is the implementation of both the IPC communication with the help of the named pipe. Now if you see the output here, so from this things will be more clear to you what the output is. So first, how you will run this program, you will write these two programs, okay, and you will open, let's say whenever we run any particular file, so we also have an option to run those files from the terminal. So you can see the terminal here. I am not running the file from the IDE, I am running it from a terminal, right? So from a terminal, what I am doing, I have opened two separate terminals here, okay, and as soon as again two separate terminals are there because we have two different files. One file name is fifo1.c, another file name is fifo2.c, and I run both the files. So suppose first I run the first file, which is mkfifo1.c. So when I run this file, so the first program, what it was doing, the first program was writing first, okay, so it was writing first and the second one was reading. This one was reading, and whatever it is reading, it is displaying it on console to us that I read this particular thing. So and from where it is writing, or where it is writing into the mkfifo file, and what contents it wants to write, that will specify. So suppose at this particular file, at this particular point, the file one, first I run this file, run program one. Now here the second console is open. Now I run p2 here. Now when I run p1 here, it asks, there is a prompt here and it asks me to write something, because again which content I want to write in p2, that I need to specify. So I have written here hello, that this should be written into the p2 program. So as soon as I write hello, here you will see that user, this output here, user1 hello, then that this means that this hello is being read by this p2 program here. So this one p1 has written the this particular string into p2. Now next is, now what will happen, now this particular file p2 will write and p1 will read, okay. Now till this point we have already seen, now again a cursor comes here and now I write here, now I write hey here. So I write hey here, so automatically I will see user2 hey, automatically the hey will be reflected in the second terminal here. And then again what I do, I write here, okay. Now I write here, I write WhatsApp, and automatically this is read here, okay, at this particular time WhatsApp, okay. So you can see that I am doing this communication between two processes. So you can see these are two different processes. mkfifo1 is first program, the mkfifo2 is the second program. Both are two different processes, and how we are communicating between them, this is shown in this particular example, that how we are exactly communicating between these two processes. But you can see that at one particular time the process can only read and the other could only write. It is not full duplex kind, that both the process can read simultaneously or both the process could write simultaneously, something like that. No, it's only the half duplex, that at any given point of time one process would be reading and the other process would be writing. So this is how this particular program is being implemented. Now the second you can say topic which we have here is the message passing. Now message passing is also another form of inter-process communication. So first we already saw what are named pipes or FIFO. Okay, this we have already seen. The second is the message passing. So message passing is also another form of communication. Processes can communicate without any shared variables, therefore it can be used in a distributed environment. So so apart from message passing, there was also another technique which was known as shared memory. Okay, so the advantage of message passing over shared memory is reflected in this statement, which means that the advantage of message passing is that they do not need shared variables to be implemented. They can run without using the shared variables, and which is good. How this is good? Because we can use it in the distributed environment. It can be used in the distributed environment on a network, so this is good that way. And it is slower than the shared memory network. That's a disadvantage. So this is slower than the shared memory network, because obviously you are in the distributed system, so maybe that might hamper its performance. And it has two actions, that is sending and receiving the messages. So how this is done, so how this is different from the named pipe? You have process 1 here, you have process 2 here. What process 1 is doing? Process 1 is sending the message in a message queue, and process 2 is receiving it. Now how this is different? With the help of this message queue, you can keep on storing the messages that you are receiving. That is the main advantage of the message queues. And this is asynchronous. That means things are not happening at the same time, which means that, let's suppose message I have message 7 coming up at some time, then after let's say 10 minutes message 6 comes, then message 5 comes, then message 4 comes. So the messages can keep on piling in a queue, and it could happen that at one point there could be many processes that are sending the messages, but there is only one process that is receiving the message, because I have the ability to store the message in a queue. I also have the ability to give priority to a message. This is important. So I can give priority to the different messages, like maybe I have received some set of messages, I can prioritize them. And maybe the first message which I want should be received first, I can give more priority to this message, and this message would be receiving first by process B. So that's the major advantage of message queue, that it allows you to assign priorities to the messages. Now, so this is the explanation. The message queue is a buffer that is used in a non-shared memory environment, where the task communicate by passing messages to each other rather rather than by accessing the shared variables. So event are asynchronous in this particular case. So asynchronous means when a class sends an event to another class, rather than sending it directly to the target class, it passes the event to the message queue, the OS message queue. The target class retrieves the event from the head of the message queue when it is ready to process it. Synchronous events can be passed using triggered operations instead. And many tasks can write messages into the queue, but only one can read message from the queue at a time. So the reader waits on the message queue until there is a message to process. So that's this I already told you, that you have the option to keep piling your messages. And obviously we can have many messages here, but and when there is no message, so obviously the receiver will wait for the message to be received. And if we have multiple messages, so we can keep on aligning the messages with different priorities, and based on the priorities the message are being read by process B. So this is the implementation of message queues in the C program. So we have how they again how this message queue is being implemented. So we have two programs here again. one is the writer process, one is the reader process. Then we have some header files that are being included. We have defined the structure for the message queue. So we'll be using the structure data structure to implement the message queue here. Now what would be the contents of the message queue? It has message type and message text as the option. That what is the message type and what is the message text here. So if you see in the main program, what I have done, I have used a function to generate a unique key here. So this is the key which is being generated. Then I create a message queue here. So this particular function, it helps in creating the message queue with this permissions and having this key here. And what I will do, I will first, since this is the write program, I will first write the particular message into the queue. Okay, because in this particular case I will write the message into the queue. So I what I'm but and where I will get the message from, I will get the message from the standard input. Again, that means that the user will be writing the message from the standard input, and then I would be sending that message with the help of the message send system call. So these all are the system calls that helps in achieving the message queues operation, the IPC operation. And then you display the message that is being received from the standard input. Again, in this particular case, I have the same structure defined. I now in this particular case, what I will do, I will create a message queue again. Okay, but in this particular case, I want to read the message. So what I will do, I will use MSG RCV message RCV system call to receive the message. So MSG send is used to send the message, MSG RCV is used to receive the message, and then that message is displayed, and this is used to destroy the message queue. Rest all the other parameters that you see here, that these parameters you have to explore yourself. That's why I'm not explaining them in detail. These parameters, these systems call these you have to explore yourself. I've just tell you the general syntax or the general overview of the entire program, that how message queues are being can be implemented in your C program. Rest all the different parameters you have to explore yourself. And then when I run this particular program, I got this particular output. So again, the two terminals, the two different programs are being run, first the writer and next the reader one. I write this Geeks for Geeks because I took this example from Geeks to Geeks. So I write Geeks for Geeks. So the as soon as I write Geeks for Geeks, the output is display here Geeks for Geeks, and this is just an acknowledgement which tells me that okay, the data is being sent here. The data sent here is Geeks for Geeks. Another implementation I had, another implementation, yes. So this is your lab manual, the lab 10, which has three programs written. So program 1 is uses the named pipes, as I already told that the first would be the named pipe. So this one is the named pipe. So this we have already seen the example of two programs. The first was reading, the first was writing, and the second one was reading. So this was the named pipe one. The second program is the message queues, and the message queues is being implemented here. So this is another implementation of the message queue. The difference here is that, as you can recall, in the message queues that we have just studied, I told you that we have the option to assign priority to the different messages, and that is being implemented here. So here there is a parameter which gives priority to your message, which is this. So this is the priority of the received message, which will be on the consumer side. So consumer reads the message on the basis of this priority. So you can see the priority parameter is specified here, that whatever message you are receiving, you need its priority also to see whether the message you are receiving has high priority or low priority, or any other message we need to read first. And rest attributes are same. So again, we have here there are two let's say variables that are specified. One is the maximum size of message, and another is the maximum number of messages in the queue. So what is the maximum size of each message, and what could be the maximum number of messages in the queues? Both are listed here. And then I set the message attributes. So here I set the max message, here I send the message size here. Then I create the message queue here. Again, the message queue is being created. You have two operations here. If it's not created, then create it, otherwise you read or write it, whatever is the operation. And then producer, what it is doing, producer is producing the message that needs to be sent. So hello world is the message that needs to be sent. Here in this particular case, what we have done, we have hard coded the value in the program itself, that this is the message which I will be sending. In those cases, what we had done, we used to take the input from the standard input from the user itself at that particular time dynamically. But here the values are static, means at this particular point only we are telling that what would be the message that would be that we will be producing. So this will be the message that will be producing, and the consumer process will be receiving the message. And these are the error conditions. What are the error conditions here? And some priorities also that is being reflected. And obviously the buffer, because you need a buffer where you can keep on storing the messages, so there will be a buffer. And that's how the second program implements the message queues. So this was about the message queues that you will have to implement. And these are some differences between named pipes and message queues in operating systems. Like what, like on the basis of communication model, if you see, the named pipes, also known as first in first out, allows the unidirectional communication model, where the data is written by one process and and is being read by another process in a sequential manner. So we saw in the FIFO part that the data was being implemented in the sequential manner. On the other hand, message queues were facilitating the bidirectional communication, allowing processes to both send and receive messages independently. Though we have not implemented the bidirectional part, but the advantage is you can implement it using the bidirectional mode also. Then message persistence, this is important. You know that in case of the FIFO one, in case of named pipes, we cannot store our messages, so that is one of the disadvantage there. But in the message passing, we have a queue there, a queue that is being listed, a message queue, which allows you to store the messages. So we have the option to store the messages and allow them to stay there. So message persistence is easily implemented in message queues. So this is one advantage of the message queues. Then message prioritization. So message queues often support message prioritization, which we know that you can associate priority to different messages, and based on that you can see whether you want to read that particular message or any other message. So that is one thing. Scalability, named pipes are typically limited to communication between processes on the same machine, as they are based on file system. So because we used to create the file system, the FIFO file, so obviously that file could be stored locally on your system only, whereas we saw that the message queues, it is a distributed form, so different machines could also access it, or on different machines also we can implement the message queues. Lastly, security. So named pipes are subject to file system permissions, which can be used to control access to the pipe, and message queues on the other hand often has their own access controlling mechanism, allowing for finer security control. So obviously named pipes uses the file system mechanism. So whatever security, the permissions which we saw are associated with the file tag types, that are used to control the access. Like if we want to give only the read permission to the user, or we want to give him read and write also, or read, write, execute all the permissions, so that is the access mechanism there in that particular case. So that's it. And finally, the last program, the third program. So third programs uses these two functions, the p open and p close function. So what you have to do in this particular third question, you just have to implement the p open and p close function. So what this function does, whatever command we specify in the p open function, it executes that particular command. So how that is done, so here is the popen function that I am doing, I have written. So popen, and this is the shell command that I have written, ls slash etc slash. So ls is the shell command that lists all the files that you have in your current directory. So here I have written that list all the files in this particular directory here. So it will, what it will do, it will just execute this particular shell command. And then if the pointer is, obviously if the return value is null, then I can get the output that failed to execute the command. Otherwise, uh, otherwise what I'll do, I'll read the output of the command. So this if gets, what it is doing, it is reading the output of the command, it is displaying it, and then p close is closing the pipe that you have just opened. So then the third program, you just have to implement the p open and p close functions. So just to recall, first named pipes, we have already seen how this one program is writing and the other program is reading, and vice versa. So first is the named pipe, second is the message queues that ensures that how two processes can communicate in a distributed systems also, because we don't have the concept of storing the information in any local file. And third is the popen and pclose functions, which is used which is popen and pclose functions. So in this third program, you just have to execute these two functions here. So obviously the third program is the one which you will be doing in the class, and you should know what the first two programs are doing. So I can ask what exactly the first two programs are doing in the class 5 also. So that's it. um, so thank you everyone.